2 on DC fundamentals, the resistance. So resistance. In a water system, a reducer can be used to control the flow of water. In an electric circuit, a resistor can be used to control the flow of electrons. So this is how we use a reducer to control the water flow. In the electrical circuit, we use the resistor to control the current flow or the electron flow. The resistance, an ohm, is the unit of the resistance to the current flow. The symbol is used to represent an ohm, which is this omega. The letter R, which stands for resistance, is used to represent ohms. An ohm is the amount of resistance that allow 1 ampere of current to flow when the applied voltage is 1 volt. So basically R equal to E divided by I. When we have E equal 1 volts and the current equal 1 amps, that's the time we have 1 ohms. Another factor an electrician should be aware is that anytime a current flows through a resistance, heat is produced. That's why a wire becomes warm when current flows through it. The elements of an electrical range become hot, and the filaments of an incandescent lamp becomes extremely hot because of the resistance. So here we have the formula E equal to I square RT. So this is the current. This is the resistance. This is the time T. So the bigger the current and lower the bigger resistance and the longer time, it will give us more heat. Use of resistance. So we use the resistor to limit the flow of the current through the circuit. So for example, we have a circuit like this. We have 15 volts. Here we have 30 ohms resistance. So what's the current? By using Ohm's law, I equal E divided by R. So here we have 15 volts divided by 30 ohms, which will give us 0.5 amps. So if we change the resistance, if we change it to 15 ohms, what will give us? That will become 15 ohms, 15 volts divided by 15 ohms, which is 1 amps. So that will give us a bigger current. Resistance of the conductor. Resistance of a metal depends on, so it will depend on type of material, conductor length, cross-sectional area, temperature. Resistance of a conductor directly proportional to the length of the conductor, inversely proportional to its cross-section area. So that's the relationship to the length, and this is a inverse proportional to its cross-section area. So it's 1 over A. Conductor of the resistance, so mathematical relationship is R equal to rho times O over A. So this is a resistivity in ohm meters, and L is the length. This is the cross-sectional area in square meter. So R equals rho over A. That's the formula we use when we have a conductor, and we have the length, and we have the cross-sectional area, A. So for example, let's find the resistance of the copper conductor, which has a length of 5 meters, and the area is 10 square millimeter, and the resistivity is 1.77 times 10 to the minus 8. So this is we can get from the table that the resistivity is based on the material. So R equals, so the formula is R equals rho times L over A. So this is rho, the resistivity, rho equal 1.77 times 10 to minus 8. And A is 10 square millimeter. So we gotta convert that guy to the square meter. So 10 times 10 to the, so 1 meter equals 10 to the minus 3. 1 millimeter is 10 to the minus 3 meter. So that would be 10 to the minus 3 square meter. Then we just need to kind of plug in the numbers to the formula. Rho times L over A. So rho is 1.77 times 10 to the minus 8 times the length, which is 5 meter, divided by 10 times 10 to the minus 3 square. Then we can get the resistance, which is 0.0089 ohms. So from the table, we can get the resistivity of different materials. Different materials have different resistivity, which is rho. So that's based on the material and the length and the cross-sectional area. Sometimes if we get square, what can be given is this side, the length of this side. So we still need to calculate the area of the material. So A will be the L square. And even if it's a circle, that would be A equals to pi R square. Temperature effect. For most conductor, a temperature increase causes the increase of the resistance. Increase is relatively linear, said to have positive temperature coefficient. Semiconductor and insulator. Increase in temperature result in decrease in resistance, said to have negative temperature coefficient. Resistor type. Fixed resistor have only one ohmic value, which cannot be changed or adjusted. There are several different types of fixed resistors. Different type of fixed resistor. So molten carbon composition, carbon film, metal oxide, wire wood, integrated circuit package. Resistor type. One of the most common type of fixed resistor is the composition carbon resistor. Carbon resistors are made from a compound of carbon, graphite, and a resin bound material. So this is example for the resistor. We have insulating code, color code, and a carbon composition. That's the lead for the resistor to metal lead. The color code. The value of the resistor can often be determined by its color code. The color band represents numbers. Each color represents a different numeric value. So let's say black is 0, brown is 1, red is 2, orange is 3, yellow 4, green 5, blue 6, violet is 7, green 8, white is 9. And this is the tolerance. We have silver, gold, red, brown. So this is the color we could have on the resistor. So they have different colors. So this is band 1, band 2, band 3, band 4, or band 5. So this is standard color code. We have 5-band resistors. We also have 4-band resistors. Depends on how many bands we have. So we have band 1, a different color. The color have numeric value like 0 to 9. Band 2, same thing, have black, brown, red, orange, yellow, green, blue, violet, green, and white. Depends on if it's a 5 bands or 4 band. We have a third band. If we use or not, have another digit. So this is a multiplier. Black have 1, brown is 10, red is 100, orange is 1000, yellow is 10,000. So we just add 1 more 0 at the back each time. So this is the tolerance. We could have silver, gold, or brown. Color code. Resistors that have tolerance of 20% have only 3 color bands. Most resistors contain 4 bands of color. For resistor with tolerance that range from 10% to 2%. The first two color band represent number value. The third color band is the multiplier. So we have 4 bands. This is band 1. This is the number, first number, and 1. This is the second number. This is a multiplier. And this is the tolerance. This means to combine the first two numbers and multiply by the resulting two-digit number by the power of 10, indicated by the value of the third band. The fourth band indicates the tolerance. So we have two numbers, n1 and n2, and we have the multiplier. Then after that we have tolerance. So basically, let's say the first one is 1, the second one is 2, and the multiplier, let's say it's 3, that means we times 1,000. If the multiplier is 2, we times 100. And after we get this number, that's a 1 and 1, 2 times 1,000. And after that, we times the tolerance, let's say 5%. That's how we read the color code. For example, assume a resistor has color band of brown, green, silver. So we have brown, green, red, and silver. The first two bands represent number is 1 to 5. So brown is 1, green is 5. And the third band is red, which the number for red is 2. Silver is the tolerance band. So brown is 1, green is 5, red is 2, so the multiplier is 10 to the 2. And after that, we times the tolerance, which is silver. Silver is 10%. So times 10%. Plus minus. So if we have plus, so that would be our tolerance here. That would be plus minus. So it could be the maximum value is plus 10%. The minimum value will be minus 10%. So this is just our tolerance. So basically for a resistor, if it have 1500, so that would be 1500. The tolerance is times 10%. So it's 150. So that's our tolerance. So the minimum value will be 1500 minus 150. So that's our minimum value. The maximum value will be 1500 plus 150. That will be 1650. So anything between that will give us 1350. So for this resistor, anything between 1350 to 1650 ohms, the value is very reasonable because it has a tolerance of silver, so which is 10%. So this will be our maximum value. This is the minimum value. So the first band is the tolerance band. The tolerance band in this example is silver, which means 10%. This resistor should be 1500 ohms plus or minus 10%. To determine the value limit of this resistor, find 10% of 1500 ohms. So 1500 ohms times 0.1 equals 150. This is tolerance value. The value can be ranged from 1500 plus 10% or 1500 minus 10%, which is 1350. So that would be not volts, that would be ohms. Sorry about that. Because that's a resistor, so the unit is ohms and the symbol is omega, not V. Gold and silver as multiplier. The color gold and silver are generally found in the fourth band of a resistor, but they can be used in the multiplier band too also. When the color gold is used as multiplier band, it means to divide by the combined first two number by 10. When silver is used as a multiplier band, it means to divide by the combined first two numbers by 100. For example, assume a resistor has a color band of orange, white, gold, and gold. The value of this resistor is 3.9 ohms, with a tolerance of 65%, orange 3, white 9. Gold means to divide 39 by 10 equals 3.9, and gold in this fourth band means 5% tolerance. So let's look at this example, read the resistance. The brown fifth band indicates that the resistor has a tolerance of 1%. To determine the value of 1% resistor, the first three bands are the numbers, and the fourth band is the multiplier. In this example, the first band is brown, second band is, which is 1 here, second band is black, which is 0. The third band is also black, which is also 0. The fourth band is brown, which is 1. So the value of the resistor is 100 times 10. So the brown is 1, so the multiplier is 10 to the 1, which is 10, plus minus 1%. So the total value for this resistor is 1000 plus minus 1%. Example 4, a 5-band resistor has the following color bands. First band red, second one orange, third violet, fourth band red, fifth band brown. The first three bands represent number values. Red is 2, orange is 3, violet is 7. Red is the fourth band is a multiplier, which is 2. The brown is the tolerance, brown is 1. So we'll have 237 times 10 to the 2 plus minus 1%. So the value for this resistor will be 23,700 ohms plus minus 1%. Variable resistor. Resistance may be changed or varied. Adjust volume, set lightning level extra. Two terminals fixed to the end of the resistor. So that's something like this. The two ends kind of fixed, and there's also middle terminal. If we connect to something else, that can be changed. That terminal 1, 2, 3. So if we use 1 or 2, that's 4 orange. And either 1, 3 or 2 and 3, that can be changed. Conductance, measure of a material's ability to allow flow of charge. Conductance, reciprocal of resistance unit is Siemens. So G equals 1 over R. And the unit is Siemens, symbol S. Measure resistance, the ohmmeter. So we use ohmmeter to measure the resistance. So let's say if we have a resistor here, this is how we represent the resistor in the circuit. We have to isolate the resistor from the circuit, then plug our ohmmeter right on it. So generate part of the multimeter steps. So that's our ohmmeter steps. So we remove all the power source to the circuit, isolate the component, connect the probe across the component. Ensure ohmmeter is set to correct range. Ensure ohmmeter is set to correct range. So basically, we just need to grab the resistor and connect that to the ohmmeter without anything else. It has to be by itself, isolate from other component. Sometimes we have short circuit, that means the resistance for the resistor is 0. So R equal to 0, basically that's just kind of piece of wire. We say that short. Low resistance conductor, it's conducted. Low resistance conductor is connected between 2 points in a circuit. Current will bypass using path of the lowest resistance. Ohm meter indicate a very low or zero resistance when used to measure a short circuit. Open circuit. Conductor is broken between points and their test. So we connect the voltmeter here. If we use the voltmeter, that will give us the full voltage. Because here is there's a broken circuit, there's no current flow. Because we have open circuit. There's an open here, so the current cannot flow. There's no current. If we plug the voltmeter here, that will give us the full range of the power source. Ohm meter indicates infinite resistance when used to measure an open circuit. So for open circuit, I equal to infinity. So when we try to use the ohm meter, that will give us our infinite resistance. That's kind of what everything about the resistor. So we need to know the color codes. So we need to convert the color to different numbers, then get the value for the resistance and Ohm's law. That's how we use the resistor in the circuit. And how we test the circuit when we have a short or open circuit. And we have short circuits. We also need to know how we can calculate the resistance when we have material rho R equal rho times R over A. When we have different material, R equals rho times L over A. So that's something basic about the resistance. Thank you for watching.